So with that, I'll now hand over to our next company. And so Aaron and Lucas will share PlasmaFresh with us. Cheers.
Hi, good afternoon. My name is Lucas. I'm the CEO of PlasmaFresh. This is Aaron, our head of operations. Thank you very much, Deep Tech Labs and Northern Gritstone, for the opportunity to join this program and to present to this amazing crowd. We are a spin-out of the University of Liverpool, revolutionizing food safety with cold plasma. As you're probably aware, food manufacturers invest a lot of resources and time to make sure that the food you eat is safe. Greencore, for example, one of the biggest sandwich manufacturers in the UK, invests almost £200,000 only on sunny wipes every year to clean conveyor belts. Now, although food manufacturers take food safety very, very seriously and do disinfection processes multiple times from farm to fork, food recalls are still very frequent. So every year, food manufacturers spend billions and billions of dollars in food recalls related to bacteria. When things go very bad, CEOs can go to jail because of food recall related to bacteria. And unfortunately, every year people die. For example, in the US last year, 11 people died due to a food recall in bacteria. This year in the UK, 3 people have already died in similar cases. Now, at the core of the problem of food disinfection are the technologies being used. They are obsolete and unsustainable. People today use UV lights, steam sterilization, sunny wipes, washing, and chemicals. We believe we can do better than that. So we are developing a technology that has a higher efficiency than UV lights, can save up to 90% electricity compared to steam sterilization, can save at least 2 hours per week of production downtime, doesn't use any water, which is a main source of bacterial proliferation and one of the most important ESG targets for food manufacturers. And we don't use any nasty chemicals. Just to give you an example, if you ate oats today, it had to be disinfected 5 times using phosphine gas. Imagine if you could remove that. And that's what we are trying to do here using a technology called cold plasma.
So what is cold plasma? Well, you're all familiar with plasma in nature in the form of lightning. And what we're trying to do at PlasmaFresh is like making lightning in a box. So we're generating cold plasmas in controlled, confined environments. When we generate a cold plasma, we generate a cocktail of reactive gases. And it's these reactive gases that are effective at killing pathogens such as bacteria, viruses, and fungus. So it's not difficult to generate a plasma, but what is difficult is by trying to scale these plasmas up and being able to control that plasma chemistry. So you can see one of our prototypes in operation here. We've been able to achieve this through complex plasma power supply architecture, as well as a patented approach. We can generate plasma across the surface of a conveyor belt. When we zoom into the plasma, we can see these little micro discharges dancing around. These are what enable us to achieve dry decontamination, so require no water or liquid chemicals. The process is energy efficient, so we don't require, this system here runs at the same amount as a household kettle. And when we generate these type of plasmas, they're generated at or near room temperature, so we don't have any thermal degradation of the food or surfaces that we treat.
So as you can imagine, this technology have potential multiple applications in the food industry. We are focusing in 2 main applications: disinfection of equipment and disinfection of food. For equipment, namely the conveyor belt, because that's the most important equipment. That's where the food touches before getting to the consumer. In relation to food, we are disinfecting powdered food. This is a very hard food to disinfect. If you ate bread today, you probably ate insects as well. So we spoke with multiple, yeah. I'm making everyone review like their breakfast menu, but so we spoke with multiple people in the industry, and the fact is, it's very hard to kill insect eggs in flour. Spoiler, plasma potentially can do this. So in terms of market, we are targeting initially the UK, US, and Europe. These are more advanced markets for the food industry and more prone to adopt new technologies. For the conveyor belt, we aim at a potential revenue of £60 million over the next 5 years with a potential margin of 50%. When you look at the food, the powdered food, this is a much bigger market. We can get to a potential revenue of 230 million over the next 5 years, and here we are not yet talking about the emerging markets, and these are massive markets. As you can imagine, herbs and spices, ingredients, they usually come from poorer countries that have lower sanitation. So we literally have the potential to change the world here. For you to have an idea of what the product look like, this is our first product, a retrofitted plug-and-play system for continuous dry decontamination of conveyor belts. There was a lot of engineering here because we need to make sure that the system can stand the very aggressive environment of food manufacturers. And this will be ready in 3 weeks. 3 weeks. Now I have 100 witnesses for that. We have the first trial. We're very excited because we have a first trial in one of the biggest food manufacturers in the UK this summer. Now, we raised capital twice. Last time was literally last month. We received money from the last investor this Monday. We raised about £1 million. This will allow us to take product 1 to commercialization, product 2 also to commercialization for small and medium volumes of powder. Also allows us to expand our patent portfolio from 4 patents to 2 patents. And then in the next round, probably in 12 months, we're gonna raise from 3 to 5 million pounds. This is a bold roadmap, but we are confident that we can deliver it because we have a very strong team with more than 25 years experience in cold plasma research and more than 30 years experience in the food industry and related industry. I joined the company last year when I was sitting at your seats doing my MBA, literally in this classroom. I met these 3 brilliant founders who are here and they're in the crowd doing an MBA consultancy project. As I mentioned, we are not raising capital at the moment, but we want to start the relationship with investors that are interested in this thesis and who would like to keep updated about our electrifying journey. Thank you very much.
Fantastic. Okay, let's move into the Q&A section. So any questions from the audience or online audience? Do you have a question here?
Hi there, thank you so much. Question about whether you'd look to apply this in pharmaceuticals or medtech, other markets where there's issues of contamination, and then as well within food, you know, infant milk, an example where there's been tremendous cost. How should one think about the safety of what you're doing?
So infant milk is very interesting because the second product line is literally for that. So it's powdered food, and it is an issue. So we are targeting related to pharma that this can be a new segment, but it's a more challenging one because in pharma, in the food industry, you want to get reduction of 99.999% of bacteria, or you add a 19 there. In pharma, you want 0 and 0. So it's just more challenging as an entry market, but it's a much bigger one.
Thank you.
I think we've got a question all the way at the back first, I think, and then one further down. So can we, if you wouldn't mind waiting to the microphone, then we'll be able to make sure that we can hear you. Thank you.
Sorry, just on the food itself. So is there any degradation of the microbiome? I mean,
So
do you contain that purely to the surface it's working with, or what happens
it's
to
a
the food?
surface treatment, so we're looking at just decontaminating the surface of whatever product that we treat. There's obviously, we'll have to go through certain regulations and test them to see what effect they have on the food. But what we've seen up to now, it's just a surface treatment, no effect, we just kill the bacteria.
And I think there's another question down here.
Thank you. Just a follow-up science question, just on the food application, whether there's any potential change in the consistency or the taste. So I was aware of a company doing something like this with ozone a while ago, and that was one of the challenges when they use lipids.
One of the companies that we're working with is Camden BRI, so they're our external partner. So we're doing a lot of testing through them. So we've got a part of the trial that we'll be doing with the powder system. We'll be looking at how we treat the powders and then looking at the food.
But what you can do to powdered food is to activate powdered food, functionalize it. So if you treat flour, for example, you improve certain qualities of the flour, which make it much more valuable. So there are a few startups using plasma just for functionalization. But as we can control and modulate the plasma you're producing, it just like kills the microbes and has minor effects like on the organoleptic properties of food.
Good. Well, thank you very much.
Thank you.
So why did we like PlasmaFresh? Well, obviously food safety is critical, both on the economic side, but also from the life, so the lost due to this and illness. So massive market, and I think as you rightly point out, there are many different markets that this can go after. The existing solutions are costly and they don't really work well. I mean, having to sterilize something 5 times with a gas is expensive and also not effective. So this lightning in a box is really powerful, and the ability to control that to produce the right chemicals from the air is incredibly powerful. I think we also got really excited about the fact that they can start